Assalamualaikum warahmatullahi taala wabarakatuh, and hi, and have a good day to Madam Irma. Uh, Introduction. Uh, this experiment given to us to replace face-to-face lab session, which was cancelled due to the pandemic COVID-19. We were given 3 weeks time to finish this experiment. In this experiment, we need to do experiment regarding Bernoullis theorem. According to the Bernoullis Principle, when area available for the fluid to flow decrease, then flow velocity of the fluid increase, and at the meanwhile time the fluid pressure or the fluid potential energy decreases. Bernoullis principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid potential energy. This principle was named after the Daniel Bernoulli, who first write this principle in book named Hydrodynamics. Basic concept. So we move to the basic concept. According to Miller, 1996 law of conservation of energy was the main driving factor behind the derivation of Bernoulli principle. Bernoulli principle state that in a steady flowing fluid, the sum of all mechanical energies, including kinetic energy, dynamic heat, fluid pressure, and potential energy, should remain same at all the point of the flow. Therefore, if any type of energy increases, like kinetic energy increase, then the other type of energy, like potential energy or pressure, will decrease to make the final sum as before. According to the Bernoulli equation of a flowing fluid, there are three things, which is pressure head, kinetic energy, and potential energy. From Bernoulli principle, it can be stated that the density and pressure are inversely proportional to each other, means high density fluid will apply more pressure while moving than the low density fluid. The objective of this experiment is first to use the ventrimeter apparatus to study the effect of area and the flow velocity and fluid pressure. Second is use the Bernoullis equation to compare the behavior of ideal and real fluid.
The apparatus that we need to conduct this experiment are: first, water container; second, measuring cup; and third, ruler. First, measure the diameter of the pipe from the water container. Second, fill the water container with water. Third, measure the height of the water inside the water container. Fourth, open the pipe at the bottom of the water container for 5 seconds. And measure the volume of the water that was filled inside the measuring cup. Lastly, repeat step 4 for 5 times using different height with constant time.
Based on the experiment that has been done, the diameter of the pipe D is 0.018 liter and the time taken is 5 seconds. For the diameter of the pipe, we can calculate the area of the pipe D. The area of the pipe A is 0.000254 meter square. Based on the experiment, the data that has been collected is the height of water and the volume of water. Based on this data, we can calculate the volumetric flow velocity and flow rate. For the volumetric flow, Q experiment, Q is equal to V over T. V, for example, V 2.67 times 10 power of negative 3 divided by 5. Q is 5.34 times 10 power of negative 4 meter cube per second. For velocity experiment, V is equal to Q over A. Q 5.34 times 10 power of negative 4 divided by A 0.000254 meter square. And the V is 2.10 meter per second. For the velocity theory, V is equal to square root of 2gh. From this equation, we can obtain the value of V is 2.12 meter per second. And lastly, for the Q flow rate theory, Q is equal to AV, A 0.000254 meter square times V 2.12. Q is equal to 5.38 times 10 power of negative 4 meter cube per second.
From this experiment, we can see that as the height of water decreases, the velocity of water also decreases. In the first experiment, the height of water was 0.5 meter, while the velocity delivered was 3.12 meter per second. Meanwhile, in theoretical value for experiment 1, the velocity calculated using Bernoullis theorem was 3.13 meter per second. The reading data might have a slight error due to in our measurement and parallax error. Other than that, some random errors also might happen during conducting our experiment. As you can see here, both graphs that was tabulated based on the data obtained shows that the velocity of water is directly proportional to the height of water. As the experiment repeated for 5 times, it caused the pressure drops and produced low velocity of fluid when the height of water falls.
In conclusion, we as a group managed to achieve the objective for this experiment. We managed to investigate the validity of the Bernoullis equation when it is applied to a steady flow of water. Bernoullis equation can be a statement of the conservation energy principle appropriate for flowing fluids. The qualitative behavior of the Bernoullis is a lowering of fluid pressure in region where the flow velocity is increased. We are also able to design and carry out the suitable experiment for our project. For this project, we just simple apparatus that we already have in our home, so such as a measuring container, measuring jar, water container, and ruler. This show that the fluid and the Bernoullis equation are very useful in our daily life, even though we do not notice them. Other than that, we successfully analyzed the data and interpreting the result for this experiment. From our data and calculation, there is slightly error in theoretical and experimental value for velocity. Experimental value can be obtained with parallax error. Otherwise, we use a ruler to measure the diameter while we should use a vernier caliper in actual lab experiment. This experiment has been carried out by us and prepared by the proper report. Thank you.